All right, so we're going to start notes on deductive reasoning. And just for definition wise, deductive reasoning is the process of drawing conclusions based on premises or statements that we assume to be true. So we're going to be studying three laws of logic, or three laws of deductive reasoning. And we will be law of detachment, the law of contrapositive, and the law of syllogism. Okay, so the first one is the law of detachment, and over here you see it in symbol form. So you have the if P then Q, so remember that arrow represents a conditional statement, and all of the laws will start with the P arrow Q. Okay, so the law of detachment, think detach to break apart. So now we're going to split apart the conditional statement. So now they're going to tell you if P is true, therefore Q is true. Okay, and so this thing that's underneath the line is the conclusion. So again, what comes underneath the line is the conclusion. So this is in a symbol form. So basically, we're going to diagram statements to see if they actually match the symbolic form of the detached law of detachment. If it does, then we can draw a conclusion. If it does not, then we'll call that one invalid. So let's go ahead and practice. So we have if Mark saves $30, then he can buy a new video game. Mark saves $30. And then we want to figure out what the conclusion is. So remember, we need the diagram, meaning in the first statement, we need to mark the hypothesis and the conclusion. So Mark saves $30 is our P statement. Okay. And remember, they always start if P, then Q. And it says, then he can buy a new video game. So that he can buy a new video game is our conclusion. So that's our Q. And again, remember, it'll always start this way. So now our next part says Mark saves $30. So what we see is that actually matches our P statement. So this here is your P statement. Okay. So then we kind of want to diagram this out. So the first statement or the first sentence went P, then Q. And then the second statement was P. So as we can see, it matches the law of detachment that's up here. So then we know our conclusion needs to be therefore Q. So now we're just going to write that in words. Okay. So we have our therefore, and then Q is he can buy a new video game. And remember, in this case, he is Mark. So you can also say Mark can buy a new video game. And that will be our conclusion. Okay, so now we've diagrammed our statement, see if it matches the law of detachment, and that it does. So now we're able to come up with the conclusion. So let's try another example. So again, remember that's the form the law of detachment needs to be in. So if we go through, if a quadrilateral is a rhombus, so a quadrilateral is a rhombus is our P. Then it is a parallelogram, so that it is, and remember the it is a quadrilateral. It's Q. Remember, they all start P to Q, so we have that going for us. Okay. So now let's look at this next statement. Quadrilateral ABCD is a rhombus, and so that matches P because we have a quadrilateral. Remember this part where it says quadrilateral ABCD is just the name of the quadrilateral. So then that's a P. So then we have our next part, which is a P. So it goes P to Q, then P. So that's matching our law of detachment. So therefore, our conclusion should be Q. So then if we had to actually write our conclusion out, we can say therefore Q, or therefore, move this out the way. And then we want to say quad. And so now that we know that the conclusion is therefore quadrilateral ABCD is a parallelogram because it actually matches the form. Here, all we have to do is match the symbols every time. Okay, so let's look at another, which is a non-example, because I want to make sure you know what that looks like. So this one, it says, if Miranda runs 4 laps on the track, then she ran a mile. Miranda ran a mile. So Let's go ahead and diagram. If Miranda runs 4 laps on the track, so here's your P. And it's very important to go ahead and diagram your statement so you can see what's going on. And it says, then she ran a mile, which is Q. And so again, our first statement went P to Q, and that's good. So now let's look at our second statement. Miranda ran a mile. Do we see how that doesn't match P? That matches Q about her running the mile, right? So then if we diagram that, that one says Q. So if we come over here, Q, and this is where we run into a problem because this does not match that. And they have to match exactly. Okay, so if they do not match exactly, then you'll say that there is no valid conclusion or it's an invalid argument. So it's not valid, then you can't write a conclusion. Okay, so that's the law of detachment. Let's go look at the law of contrapositive. The law of contrapositive states if P then Q, then you can come and say not Q, and then the conclusion would be therefore not P. So remember, contrapositive was the flip and negate. So we take our original, and yes, it's kind of broken apart like the law of detachment, but now we're flipping the order and negating them. Okay, so let's go ahead and try diagramming, and we're going to do it the same way. So example 1, if the shape is a square, then it is a rectangle, then the shape is not a square. So let's see if we can come up with a conclusion. So the shape is a square is your P. Then it is a rectangle is your Q. And again, remember, everything is going to start P, if P, then Q. Okay, so let's read the second part. The shape is not a rectangle. So the part that talks about a rectangle is over here, Q, but it's not exactly Q. It is the opposite of Q, or it's not Q. Okay, still use the same color when we diagram to kind of show us a relation to Q, but that it's not Q. Okay, and so that matches the law exactly so far. If P to Q, then not Q. So therefore, we know our conclusion should be therefore not P, or the opposite of P. So then we can type our conclusion will be therefore, and then the opposite of P is the shape is not a square. Okay, so now that we know what not P is, it matches now the law of contrapositive. All right, let's look at another example. If you live in Texas, then you live in the U.S. James does not live in the U.S. And so we want to know what conclusion can we draw from that. So let's go ahead and diagram. If you live in Texas, that's going to be our P. And you live in the U.S., so the you live in the U.S. is our Q. So again, we are matched P to Q. So now James does not live in the U.S. So something about living in the U.S. is Q, but it's the opposite of that. So again, this one is not Q. And that's how we'll diagram it. And so because it's not Q, it matches what we see in the law. So we know the conclusion has to be therefore not P, or the opposite of P. Okay, so then we can actually write that out. So we know it's therefore, and what's the opposite of P? You do not live in Texas, or in this case, James does not live in Texas. So again, we have James does not live in Texas. Okay, and see, we're just matching the laws exactly. So you memorize the patterns of the law, and then you have them done exactly. All right, so now we have the law of contrapositive. Now we're going to do the non-example, just so you can see what I mean. So in this one, if Malik buys a new pair of shoes, then he will be happy. Malik did not buy a new pair of shoes. So Malik buys a new pair of shoes, it's P. Then he will be happy, Q. Okay, so again, starts off P, then Q. Okay, and now this one, Malik did not buy a new pair of shoes. Well, which part talked about buying a pair of shoes? That's P, but this is the opposite of P. So this statement is not P. Okay, so we went P to Q, then we went not P, and if we look, that does not match the laws. That does not match the form the law needs to be in, so we know this one cannot have a valid conclusion. So again, we'll see that say invalid or there's no conclusion possible, whatever like that. All right, so our next law is the law of syllogism. Okay, so the law of syllogism has a couple of different forms you can see it in. So the first one, you can go if P then Q, and then you're going to have if Q then R. So you're always going to have two conditional statements to start with. And the funny thing about this one is that on the diagonal should be the same. And then so those will cancel out, and then you can say therefore if P then R. Okay. And then on the other side, we can start with P to Q. Remember, everything starts with P to Q. And then if we go if R, then P. So in this case, we're looking, can you cross out on the diagonal? And if that's the case, then you can say, therefore, if R, then Q, because then you have what's left. Make sure when your diagram is always whatever's on the left goes first, whatever's on the right. But the one thing that we can add is you can mix the law of syllogism with the law of contrapositive. So you can also have as a valid statement the contrapositive of this conclusion. And remember, contrapositive is to switch and negate. So if I switch and negate this part of the conclusion, you can end up with this. And so either one of these are valid options. Same for over here. If our conclusion was if R then Q, then another valid conclusion could be the contrapositive of that, which is if not Q, then not R. Okay, so let's go through some examples. So we have, if it is Saturday, then Jake has a tournament. So we're going to do it is Saturday. There's our P. And then Jake has a tournament is Q. And remember our statements, all the laws have started if P, then Q. It's always our starting point. Okay. Then we hear on the next conditional statement, we have if Jake has a tournament. Okay, well that here is matching Q. So that's Q. And then he will pack a lunch. Well, in no other part have we talked about packing a lunch, so we're going to use a whole different color. And then he will pack a lunch, which is R. So that's something totally new. So we have if Q, then R. And so because we have the two conditional statements, we can now look at our diagonal. Whoa, our diagonals are both Q, so they can cancel each other out. So then we know that our conclusion that we can write will be the P to R. Okay, and if you wanted to, you could also do the contrapositive of this, and it will also be a valid statement. Okay, so then you could write this out in words. Therefore, if P, then R. And so then we have our conclusion. If it is Saturday, then he will pack lunch, or you could say then Jake will pack lunch. And so therefore we diagrammed it. Diagramming your statements allows you to tell me exactly what the conclusion should say. Okay, so let's try another example. We have if school is canceled, then students will sleep. If it snows, then school is canceled. So let's start by diagramming. So if school is canceled, there's our P. Then students will sleep. Here's our Q. So we go if P, then Q. Okay, and then it says if it snows, well, that doesn't look like anything we have up there, so that got to be something new. So if it snows, here's R. Then school is canceled. What does that match? That matches P. So now we've diagrammed our statements. So now we know this is R, then P. So because we have two conditional statements, let's look at the diagonal. And in this case, it's the diagonal that matches. Well, those match. So now we know that our conclusion has to be what's left R then Q. Okay, so then you can write that out in words because now you know what the R is and then you know what the Q is. You could also do the contrapositive of that statement as well. So then we have if it snows, then students will sleep. In example 3, we just want to determine, is this a valid argument? So let's look. So this time I gave you the conclusion and we want to see if it's valid. So if the banana is brown, so that's P, then I will not eat it. And that's very true. So that's Q. And it says if I don't eat the banana, now granted that's not the same words exactly, but those are the same statements. So we just fixed it for grammar. So there's your Q again. Then I will throw it away. Well, that's something totally different. So we're going to use the letter R. And then our conclusion is if I don't throw it away. So throw away is here, but this one says I will throw away. This one says I don't throw it away. So we know this is a not R, or the opposite of R. And then the banana is not brown. So banana being brown is P, but this is not brown. So this is not P. And so we want to see if this is actually a valid argument. Not to say if it's true or false, just if it's valid. So we're just going to write out the diagram. All right, so this statement was diagram P to Q, Q to R, then not R to not P, and that matches this one where I took this form and I gave the contrapositive. So in all, this is a valid argument. Okay. Let's look at one more, which will be a non-example. So for this one, it says, if I go to the bank, so let's go ahead and start diagramming. If I go to the bank, it's P, then I will make a deposit, Q, because remember that we always start if P, then Q. And it says, if today is payday, well, I don't see anything up there about payday, so that has to be something different. So that's R. And it says, then I will make a deposit. So making a deposit, that's Q. So now a diagram, I went if P then Q, then R then Q. Oh, there's nothing that matches on the diagonals. The things that match are all on the right-hand side. So I can't cross anything out. So therefore, this is not a valid argument. I cannot write a conclusion. So in this case, I can put there is no conclusion. So there's no conclusion that can be made there because how it's stated does not match the laws that are given. Okay. So at that point, that's all it. Kind of review back over this, jot down any notes or questions that you might have, and be prepared to ask them in class.